Yes, hello students. So this is the remaining part of distributed systems unit 4. So the remaining topics we are going to cover in this video. So in the last video of unit 4, we just reached to this topic that was network file service architecture. So in today's session, we are going to cover network file service architecture along with different examples. So now what is this NFS architecture, or let's say network file service architecture? One second, I'll just make it a full screen. Yeah. So when we are saying that is a file service architecture, or we'll come to the network part afterwards, but let's focus on the file service part. So file service architecture basically consists of one client computer machine and another is the server computer machine. So you can see left hand side client computer and right hand side server computer. So obviously till now, whatever topics and important points which we have covered, there we have seen that from the client side, many requests will be given to or provided to the server, and from the server side the appropriate responses, or you can say result or acknowledgement, will be received on the client machine or the web browser, right? So now talking about the different application programs on the client computer, so these will be the different programs, or you can say, which are working as a thread on the client machine. And this is a client module who is responsible for establishing some interface. Let's talk about an API, that is application programming interface, with the server computer. So now whatever give and take, or the sending request and receiving response, this particular cycle will be done through this client module. So let's say client module from client computer, and the flat file service from server computer is establishing that bridge or connection between these two machines or entities, that is client computer and server computer. Okay, and different application programs which are running on the client side, one by one, each and every program working as a thread will be taken into consideration based on the queue or priority, right? So from the client module, you can see that here it's one elliptical shape, which is showing some kind of the connection or some kind of the communication media in between client and server computers. Okay. So this first arrow where the pointer is pointing, the first arrow which is coming from client module, it's going towards the directory service at the server computer. So this directory service, we can say that here some of the operations which will be performed will be like lookup. So lookup will resembles to the searching, finding, seeking, right? Then add name, unname, that means you are removing or deleting that name, and then get the names of different files, right? So why these specific or particular operations are written over here? Because they are related to, or we can say they are connected to the directory oriented services. So as we know the hierarchy, which starts from the root directory, then particular folder, and then we go to the specific file when we are searching for a particular file which is required from the client's point of view. So lookup, add name, unname, get names are all different operations, directory services or operations which are performed here. That's why they are labeled upon this arrow. But when we talk about the client module and flat file service connection, or establishing that relation, there we can see the different operations which are written over here are like read, write, create, delete, get attributes, and set attributes. Again, once again, these all are the flat file service or different file operations, right? So now these are not dealing with the directory, I must say, but these are dealing with the specific file, like reading a file, writing to the file, then you're creating a file, deleting a file, get the attributes of the file or set the attributes to a file, right? And then this are connected to the different data stores or databases, right? From the different, from where we are going to fetch the different files. So this is the complete file service architecture. Fine. So this is a simple file service architecture which is going to work in between two machines. But our focus, as we are studying the subject like distributed file systems or distributed systems on a large, we are concerned with the networking part. We are concerned with the www, World Wide Web part, right? So now we are going to locate, or we are going to relate, I must say, this file service architecture on the network basis. Yes. Now the first point here is like flat file service. So, as we have seen in the earlier diagram, flat file service are going to have UFIDs, that is unique file identifiers. Directory service is map, it's going to map names to UFIDs. So you can just resemble this to your tree diagram, where we are starting or we are traversing from the apex, that is the root node, till to the leaf nodes. Okay, till we are moving till the leaf nodes. So there we can say that yeah, so there we can say that when these when we are traversing from the root node till the leaf nodes, intermediate levels with different nodes at the same level are going to work with each other, right? So now mapping the names to UFIDs, that is unique file identifiers. This is the service or the task of directory. Okay, now coming to the client module, as we have seen, it is going to integrate or extend flat file and directory services. It is going to provide a common API, application programming interface, which in simple terms I was explaining, like it is going to establish a connection or communication media in between the two entities or machines, like client computer and server computer. And the third will be stores location of flat file and directory services. Whereas the stateless server, the server computer, it does not store the information in its state. It is going to just provide the data which is coming from the data stores or databases. Yeah. Now we are going to come to the case study one. The case study one, so different file systems or examples or applications which I was saying. So the first case study is virtual file system. So again, it's an example or case study of NFS, that is network file system. So virtual file system, it is like NFS is popularly and widely used. It was originally designed and implemented by Sun Microsystems. Okay, so basically Sun Microsystems. So what was the main purpose? Like all the Unix Linux based workstations and those operations were performed. Then NFS supports heterogeneous systems. Okay, it is common to find MS-DOS clients running on Intel 386 CPU, and they are going to get the services from Unix file servers. Okay, so the examples like Motorola phones, if you remember, and Sun Spark CPUs. Sun's network file system, NFS, okay, they are widely used distributed file system. So from the Sun's microsystems, this particular network file system was provided, and it uses the virtual file system layer to handle local and remote files. Now talking about the virtual file system or the NFS architecture, again, we are having client computer and server computer, but there is a slight difference because we are not studying the skeleton structure or the main structure of NFS, but we are focusing on virtual file system. So here you can see application programs are there, but these are the Unix system calls, okay, between the application programs, and you can see this kernel, right? So in this Unix kernel, we have virtual file system. Okay, then virtual file systems locally, they are connected to Unix file system and other file systems. So they are going to access this Unix file systems and other file systems within this client module. That's why local. And now through this remote connection or remote, the association or relation, NFS client is going to interact through this, communication channel or media or through this bridge with NFS server, which is located at server computer. So we'll come to this protocol and server part later. But here on the client computer, let's focus on, once again, application programs are working as different threads where they are to be executed on priority basis. And they are connected to Unix kernel through Unix system calls. Okay, so they will be fetch or access through Unix system calls. And in the Unix kernel, we are going to have important modules like number one, VFS, that is virtual file system, as we are studying the first case study, virtual file system of NFS, right? And now locally, this VFS is connected to Unix file system or other systems, and remotely NFS client at inside this Unix kernel is going to interact with NFS server at server computer. Okay, so when this communication media or this particular channel comes into picture, here one name is written as NFS protocol. So obviously this protocol will be some set of rules as the definition says, or there are some, this is a mechanism through which we are going to set those rules in between NFS client and NFS server, so that the communication or the data passing through that communication channel or media becomes easier and acceptable, right? So now the middleware which is written over here is remote procedure call, RPC, and the protocol which they are going to use either UDP or TCP, right? So this is just an example given here. At the server computer, you can see again there is a virtual file system to which we are having remotely NFS server connected, which is going to retrieve all the requests which are coming from the NFS client at client computer. And again, virtual file system is going to be connected locally to the Unix file system through which the database or data store is connected, from where the required file or the specific file will be fetched. Okay, so this is virtual file system. Coming to the second case study of NFS, that is Andrew Network File System. So it is also called as ANFS. Now it is caching. Here it is the main features are like caching in distributed file system and retaining most recently accessed disk blocks. It reduces network traffic and server contention. And scalability is an important quality attribute here. It is the most important design goal of Andrew file system. Now, coming to the, we can say Andrew file system main architecture. Now here the difference is that with these important modules, you will come to know, you can identify that yes, this is Andrew file system, or the question is asked about Andrew. The two important modules here, one at the client side, which is shown in the yellow blocks, that is Venus. Another one is at the server side, that is a set of servers, which is again shown in the yellow block, that is Vice. Okay, so Venus and Vice. So Venus at client side and Vice, that is set of servers at server side. Okay, so with these two important modules, you will come to know that yes, we are talking about, or the question is asked about Andrew file system architecture. Okay, so now here you can see a number of user programs are running on the left hand side, let's say client side. So user program, again Venus is going to interact through the communication channel or network with the Vice or set of servers. Okay, and at each and every client side you can see Unix kernel which is connected to the disk or data store or database from where the files will be fetched. Okay, and the appropriate request will be made. All these communications through each and every user program is done via the Venus. Okay, so you can see that here the Venus will be the interaction module at the client side, which is going to get all the requests coming from the individual user program, and they are going to travel or traverse through this network, and then they are going to reach to the individual vices. So again, it is a set of server through different programs, right? Number of set of servers are connected with each other. Again, Unix kernel connected to multiple disk or multiple data stores. So this is the main, summary of Andrew file system, which is focused on Vice and Venus. You can see here, Vice is server or serves files to Venus, that is on client side. And Vice is a set of trusted servers, which is collectively called as Vice. It is a process running on server side, and Vice process dedicated to each Venus client. So you can see that Vice process is dedicatedly connected or related to each and every Venus client, which we have seen in the earlier diagram. And Venus, let's say about Venus, there is a cache files from Venus. It is going to work on the cache copy, which is, or cache copy, which is present on the client side, right? So reading and writing are performed directly on the cache copy. So why it is done? Because we have seen the important features or USPs of Andrew file system, that the congestion in the network or the contention, or you can say the traffic jam, will be reduced to much more extent because work is done on the cache copy. So frequently accessed copies will be handled here in spite of, no, or you can say rather than disturbing the entire database, right? So it caches the files from Vice and it contacts Vice only when a file is opened or closed. Otherwise, all the reading and writing operations directly they are performed on the cache copy without disturbing the main database or server at the Vice side. Okay. So now the special case study is GFS, that is Google File System. So now the Google File System is again distributed file system. So never forget that WWW concept. So why it is used for data-centric applications with all these quality attributes. GFS can be implemented in commodity servers to support large scale and complex operations or file applications, okay, where high performance or, the scalability is required, high scalability is required, or flexibility is required, then only we can say the system is reliable. Google file system is designed for system to system interaction and not for user to system interaction, right? So now here we are going to focus on the important module of GFS, that is chunk servers. So obviously chunk will be one part, or you can say the sub part of a server. So chunk servers, they are going to replicate the data automatically. So this is the diagram for, you can say, the Google file system, which starts from an application, which is going to have first chunk mappings via master. And we are going to have a shadow copy of that master, that is shadow master. And through that master also, we are going to have the connections to chunk server. That is one option. Another option is through an application, the direct access to chunks are also, that possibility is there. Direct access to chunks. So you can see these arrows are going directly, they are connected to the chunk servers, or via shadow master copy, we are going to have a connection or relation to the chunk servers. All these chunk servers are connected to each other because they are going to duplicate or replicate the data. And they are the, one image of the main server. So part or subparts of the main server, or not the exact main server. Then you can see through each and every chunk server, we have file 1, chunk 1, or file 1, chunk 2, or file 2, chunk 1. So different files with different chunks are working over there. You can just go through the relations or the mappings. Then you can see that these are the redundancy. As these are the colored portions, you can see file 1 chunk 1, file 1 chunk 1. Then you can see the green ones, file 1 chunk 2, file 1 chunk 2, file 1 chunk 2. All these are the redundant or duplicated copies, right? So in this way, the Google file system is going to work for the for availability of data, I can say, because high performance and reliability is a main concern here. Now, the next important topic is naming services. Now, obviously, naming of different files, so different types or kinds of namings we are going to study here. So it plays an important role in all computer systems and especially within a distributed environment, because when we are working with www, naming systems becomes very important. So some files or some modules or entities with the same name, we have to have some kind of the separation or some minute differences in between them, okay, to identify them, to recognize them in complex applications. So the three main areas of study here are the organization and implementation of human-friendly naming systems, because they should be acceptable and easily graspable and understandable by the client. Naming as it relates to mobile entities and garbage collection. Okay, that means you should be knowing that when that name is no longer needed, what is to be done with that, fine? So now some definitions which are required to understand naming services, like an entity, just about any resource, as you have already studied in DBMS, an entity, right? So an entity can be any particular resource or module. A name is a string, often which is human friendly, that refers to an entity. Address will be the access point to the exact, I can say, location from where you are going to get that or access that or retrieve that particular file or resource. So a name for an entity that is independent of an address is referred to as location independent, okay? Identifier, as the roll number or PRN number or SSN number in other countries works. Identifier is a reference to an entity that is often unique and never reused, okay, like IDs, fine? So let's talk about properties of a true identifier. An identifier refers to at most one entity. Each entity is referred to by at most one identifier. Okay, so an identifier refers to at most one entity. So see the connection. An identifier at most to one entity. Each entity is referred to by at most one identifier, and an identifier always refers to the same entity. This is very important. So number of times we cannot change roll number 1 to number of people, right? When it is allotted to that person, it will be there throughout the complete curriculum is finished. So now there is one more important concept when naming services comes into picture, like naming versus location services. So now you can see in the A part or A section diagram, you can see all the names are directly connected to or related to addresses. So it is called as direct single level mapping between names and addresses. Whereas in B, it is much more disciplined and sophisticated format where names are connected. It is two level mapping. So names are connected or they are related or associated with the addresses through an entity ID. So here comes the concept of identifier, which is a unique one. It cannot be reused, and it is going to identify the exact location or access point of that particular file. So the upper portion where names are given to the entity ID is called as naming service, and the entity IDs which are going to locate that access point is location service. So that is the difference between naming versus location. So the B diagram is called as two-level mapping using a location service. So this is very, very important. Whenever some kind of question is asked on naming services, even though it is not asked, you have to draw it and write it down. Now, simple solutions broadcasting. So we can see broadcasting and multicasting. So like classic example will be ARP, Address Resolution Protocol, which is used by TCP/IP suite for resolving IP names to underline networking technology addresses. So just forget about this part. We want to focus on different types or kinds of naming services. Like one is flat naming, which is also called as unstructured naming. Okay, so it is just a flat sequence of charts or symbols, simple name. Okay, this you are going to also study in your SMD subject or might have studied, where we are talking about the names of entities or use cases or classes. Simple names. This is also called as simple names, flat names, unstructured names. So there is no multiple loopings allowed there. Simple name like no Anagha Chaudhary. But when we are talking about the structured name, so from where it has come. For example, now here you will be focusing from the root directory, the way you write it in command prompt. So from root directory to next folder, next folder, next folder, and then we reach to the exact file. So flat names are good for machines, not for humans, right? Yeah. Structured names are composed by simple human readable names, thus matching the natural limitations of human cognition. For example, internet name or internet domain namespace. So when you are going through URL, you always found that it starts from HTTPS in the entire directory and reach out to the exact file. So that is some kind of structured naming because it shows the exact access point starting from the root part, from where it has originated. So there comes the concept of namespaces. So now you can see what I was talking about. Names are organized hierarchically because when we are talking about structured names, we have to show that hierarchy starting from the root node or directory to the exact file or access point according to a label directed graph, which is called as a naming graph. Leaf nodes here. So you can see the leaf node is represented by the circular or circles, which are going to represent named entities, whereas the directory node are squares, which have a number of outgoing edges. And each edge is labeled with an identifier. So now you can see here, data which is stored in N1 is just connected here with a different box. Inside this box, it is written, this is the data which is stored inside this N1 directory node. Yes, so square is a directory node, so N1 is a directory node. Inside this data is shared. What is that data? N2, N3 are leaf nodes. So N2 is elk, N3 is max, whereas N4 is the next directory, which is team. Okay, so you can see that from N1, elk, max, and steam, they are connected to N2, N3, which are leaf nodes, and N4 is a directory node. Now, N1 itself is having a root node or a hierarchy, it's also called as the parent node, right? Or the root node, that is N0, which is connected via home. Now, N0 is also connected to N5 leaf node through keys. So, N4 is also connected to N5 via keys. So now, when I want to access N5, there are two ways. If I'm starting from the root node N0, the first way is directly going /keys because N0 to N5, or via the another way, that is from N0 to home, from home, that is N1 to steam, from steam it is N4, that is from N4 to keys, and then I'm reaching to N5. So you can see here the second line, that is /home/steam/keys, and now I'm at N5. So there are two ways to access or to reach to the access point of N5 or location of the N5. Okay. Similarly, from N0 to home via home N1, then from N1 to N4 via steam, and from N4 to this particular leaf node via mbox. So now how I'm going to write it? /home/steam/mbox. So this is the way of naming, or you can say this is the way of structured naming. Okay. Now the name address resolution. So you can see the iterative and recursive. There are two ways of name address resolution. If it is iterative, some kind of repetition you're going to see here. That is going to be in the cyclic form, or like this client is going to go for server 1, server 2, server 3. You can see give and take, give and take, give and take. And from server 1 to server 2, from server 3, and then so on to the file. When it is recursive, you can see from client it is going to server 1. From server 1 to server 2, you can see this 1 and 2 are connected. Then 2 and 3 are connected. And there from 3, you can see it is going back to the client. So it is in that kind recursive in nature. So this is a two-way of name address resolution. Rarely questions will be asked on this topic. So that's all with unit 4 of distributed systems. So we have covered all the topics. So other related presentations, you can just go through for more data. Otherwise, the topic wise or the syllabus point of view, we have finished all the points of unit 4. Thank you.